Okay, so let's unpack this. Imagine a device. A device that could, well, listen to your thoughts, your internal monologue,
Hmm.
and then translate that directly into words.
It sounds like science fiction almost.
Right. But here's the twist, the really surprising part. Imagine that same device only works if you give it a secret, a mental password.
Ah, okay.
And that's not fiction anymore. It's the core of our deep dive today.
Really fascinating.
Yeah, we're digging into a pretty groundbreaking development. It's
Sure.
fresh out of a Nature article looking at new research published in Cell just recently, August 14th, 2025.
Right.
So our mission, is to pull out the key insights, the surprising bits, those aha moments behind it all, how it works, who it's for.
And crucially, that privacy aspect you mentioned.
Exactly, the unique privacy feature.
Well, this isn't just a technical jump forward. It feels like a really profound shift in how we even approach human-AI interaction.
Oh,
By putting user control right there at the fundamental design level, especially for something as intimate as thoughts, they're kind of setting a new ethical baseline.
that's a great point, an ethical standard.
Yeah, I think that's the real breakthrough here, beyond just the tech itself.
Okay, so that idea of control. Let's dive into the core innovation then. We're talking about a brain-computer interface, a BCI,
Mm-hmm.
that decodes imagined speech almost in real time.
An imagined speech being.
You know that silent conversation you have in your head, your internal chatter.
Got it, that internal voice.
Exactly. And the main people this could help are individuals with severe speech difficulties, maybe paralysis or conditions limiting muscle control.
Right, where vocalizing is difficult or impossible.
And the accuracy is pretty striking. The device apparently deciphered up to 74% of imagined sentences correctly.
Wow, 74%. That's significant, especially if you compare it to what came before.
Yeah, tell us about that.
Well, if you connect this to the bigger picture,
Yeah.
a lot of the existing BCIs, they still need users to try and physically speak,
Right, attempt the articulation.
which, as you can imagine, is incredibly tiring, exhausting, really,
Yeah.
and uncomfortable for someone with those kinds of impairments.
Makes sense.
So this focus purely on internal speech, it's just a major leap for user comfort, for practicality.
It seems much more usable day to day.
Exactly. And it builds on really important earlier work. Sarah Wandelt and her colleagues, back in 2024, they developed a BCI that also decoded internal speech.
Okay.
They were looking at signals from, I believe, the supramarginal gyrus, a brain area key for speech and language.
Right, so building on previous foundations. But this privacy thing, for many people listening, I imagine the idea of mind-reading tech immediately brings up privacy concerns.
Absolutely. It's probably the first question that pops into most people's minds.
And that's where this device does something genuinely different, right? It
Yeah.
only works if the user actively thinks of a specific keyword, a password,
Yes, like a mental activation key.
which is critical. It means the system isn't just, accidentally translating every stray thought that pops into your head.
Mm-hmm. Prevents that unintended eavesdropping on your own mind, essentially.
So if I'm just sort of internally debating pizza versus pasta for dinner,
Right.
it's not going to suddenly announce pizza unless I specifically want it to, using that keyword.
That's exactly the idea. It waits for your explicit mental go-ahead.
Erin Kins, who's a neural engineer and one of the co-authors on this new study,
Okay.
she specifically said they wanted to, and I quote, investigate this robustly. They knew about the risk of accidental decoding. It was a key concern.
So it was baked in from the start, not an afterthought.
Precisely. And Sarah Wandelt, from that earlier work we mentioned, she called this password mechanism technically impressive and meaningful, and, importantly, a crucial feature for real-world use to protect privacy.
High praise from someone in the field.
Definitely. It really underlines how thoughtfully this was designed. Okay, we've covered the what and the why of the privacy part, but how does it actually work? How does this BCI translate a silent thought into, well, words, for those curious about the mechanics?
Sure. So Kunz and her team, they analyzed brain signals. These signals came from tiny microelectrodes placed right in the motor cortex.
The motor cortex, isn't that usually for movement?
Exactly. The region involved in voluntary movements.
Yeah.
Which is interesting, right?
Yeah.
The study involved 4 people, all with speech difficulties. 1 from a stroke, 3 others with motor neuron disease.
Okay.
And they asked them to do 2 things. Either attempt to say words out loud or just imagine saying them silently.
Comparing the signals.
Right. And the key finding was that both attempted speech and internal speech, They originated in the same brain region and generated pretty similar neural signals.
Huh. Interesting.
Though, as you might expect, the signals linked to internal speech were a bit weaker, less intense.
Okay, that makes sense. So they captured these signals.
Then what? Then came the AI part. They used all that neural data to train artificial intelligence models, specifically to recognize phonemes.
Phones. Those are the basic sounds of speech, like K or sh.
Exactly.
Hmm.
The smallest units, the building blocks. Once the AI could pick out those phonemes from their brain signals, they used sophisticated language models. Think of things like, predictive text on your phone, but much more advanced.
Got it.
These models then stitched the recognized phonemes together, forming coherent words, then sentences, all happening in near real time.
Wow. And they had a big vocabulary to draw from.
A very big one, 125,000 words.
That's impressive. And that 74% accuracy we talked about.
Yeah, that held true for sentences imagined by two of the participants when they were asked to think of specific phrases.
And how does that compare? Is that good?
It's really quite good. It was actually similar to the accuracy they got with their earlier BCI, the one that worked in attempted speech. So achieving that with silent, imagined speech is a significant step.
Definitely sounds like it. So let's zoom out. What does this all mean? For communication, for assistive tech, maybe even for, personal autonomy.
Well, the practical benefits are potentially huge.
For people with severe communication issues, it seems like a new door opening.
Absolutely. Offering a way to express themselves without that physical strain, maybe even faster and more naturally than some current methods.
Yeah.
But I think this deep dive really underscores something broader, too. As technology gets closer and closer to us, even into our thoughts, this whole conversation around privacy, around user control, it's not just a nice-to-have feature anymore.
It's essential.
It's absolutely essential.
Yeah.
Fundamental, really, for acceptance, for trust, for success. This research shows it's not just about what tech can do, but how responsibly it's designed.
Right, designing with ethics built in from the ground up.
Exactly.
So there you have it, a mind-reading device, basically.
Well, sort of. With a key safeguard.
Right, with that crucial built-in privacy guardrail, the password. It really is a compelling glimpse into a future where maybe technology can be both incredibly powerful and ethically mindful.
It certainly points in that direction. And it leaves us, and you listening, with something to think about, doesn't it?
Oh.
As more and more personal data, maybe even data directly from our brains, becomes accessible through technology, what other kinds of passwords or control mechanisms will we need to invent? How do we make sure our privacy, our autonomy really stay paramount in that future?
That's a really thought-provoking question to end on. What are the future safeguards we haven't even conceived of yet? Well, we hope this deep dive gave you some fresh insights today, maybe spark some curiosity. Keep exploring, keep questioning, and join us next time for another deep dive into the surprising world of knowledge.